Okay, so we're going to continue here with question 10. We're going to apply what we know about even and odd functions. I replace cosine, the even function, with cosine of x. So the negative inside just goes away, whereas this negative in tangent is going to pop out in front of the function. Likewise, sine is also an odd function, and so the negative inside of sine is going to pop out in front as well. Okay, so now I have a fraction and something that's not a fraction, and I need to combine them together. So what we need is a common denominator. So I'm going to multiply sine x by tan x over tan x. Now this negative right here can relocate to the numerator, right? With a fraction, a negative can go up or down. So 2 over negative 3 is the same thing as negative 2/3, for example. So what I'm going to do is I'm going to relocate this negative to the numerator, and that way it's not in the denominator. So now I have negative cosine x over tan x minus sine x tan x over tan x. Okay, so now when I combine this into one fraction, I have negative cosine x minus sine x tan x over tan x. Now this is not simplified, is it? You have to just keep going until you get it simplified, and sometimes it's a matter of trial and error, and sometimes you might run down a rabbit hole and have to start over. But what I would do is just throw in whatever substitutions you can think of and to see what will happen. Usually when you're trying to simplify a long expression of steps, an expression with a lot of steps to make it simplified, you're going to be not seeing the end result until later. You're going to just try things and see what happens. So I'm going to replace both of my tangents with sine over cosine. That's a good strategy. Take anything that you have and replace it till you get everything in terms of sine and cosine. That's a pretty good strategy if you don't know what else to do. So I'm replacing this first tangent with sine over cosine, and then I'm replacing the second tangent with sine over cosine, and now I have a complex fraction which I can clear by multiplying both the numerator and the denominator by cosine of x. So if you multiply by cosine of x over cosine of x, which is a form of 1, that allows us to then rewrite the numerator. We have the distributive property here as negative cosine squared x minus, the cosines here cancel, leaving you with sine squared x, and in the denominator we have sine x over cosine x times cosine x, which is just sine x. And now for this numerator, I can factor out a negative 1. Then cosine squared x plus sine squared x is equal to 1. Yay! So that's going to make this a lot simpler. Negative 1 over sine x can then be rewritten as negative cosecant x. Wow, that was a lot of work to get to our simplified answer, but that's going to happen sometimes. So let's try another one of these. Let's do question number 12. Here again we have the even odd function identities that we need. Back here, remember that we can replace sine of negative x with negative sine of x, cosine of negative x with cosine x. All of these you want to have out in front of you so that you don't get them confused. Okay, so for here, we're going to replace, I'm interested in showing a lot of steps, okay? So the negative here is just going to disappear, cosine of x. Now here, what happens to the negative? The negative pops out in front of the tan, and then this negative pops out in front of the sine. I could have used parentheses instead of brackets. I'm not sure why I used brackets, but anyway, they're fine. Now this negative and this negative will cancel. Don't skip that step because that step illustrates the use of the identity. Then we're going to end up with cosine x plus tan x sine x. So now that we've taken care of the negatives and the positives, we want to replace tan with sine over cosine. And I can see here that I'm about to have cosine as a denominator, so I can over here multiply by a cos over cos so that I will have the common denominator. And now I end up with cosine squared x plus sine squared x all over cosine x, which is going to be 1 over cosine x, or secant x. So the more you do these, the faster they get and the more natural they become. But it's a lot of trial and error, and there is no substitute for experience, okay? If you don't understand what you're doing at first, or you feel like you're moving around in a fog, don't worry. Experience through lots and lots of practice gets you to where you need. There is no substitute for experience in math any more than there is in playing the piano. The only way to get good at playing the piano is through a lot of practice. The only way to get good at math is through a lot of practice. Now, for these remaining problems, these are problems that are going to be identical every single version that pulls up on the screen, which means that if I did them for you, I would defeat the point of you doing them. Now, if you get them wrong, you will automatically have access to the correct answer. But that's not the point of this exercise. The point of these problems is even if you're given the answer, even if you knew the answer, and right now I'm showing you the answers, can you get to these answers through your own work? That's the question. Can you perform substitutions using the identity, and after a series of steps, can you arrive at these answers? Because when we do identities and we are verifying the identities, you're going to be given the left-hand side of the equation and the right-hand side of the equation. There will be no mystery as to what the answer is. Your work will be to show how you get from the left-hand side of the equation to the right-hand side of the equation. So that's what you want to do for these problems. You want to practice for yourself, how can I replace all of these values using the great many identities that I have here? What sort of substitutions can I do so that in the end everything on the left matches everything on the right? And it will take some trial and error. But you'll have no difficulty getting full credit for it because you'll have the answers here. So don't bypass the really important practice just to get the credit. Remember, the point of homework isn't just the points. The value of homework to your grade is only 15%. The real value of homework is the practice that it provides so that you can do well on quizzes and then on tests and ultimately the final exam. All right, that's it for 5.1.